You've made it to Part 4 of Chapter 8 Review. Way to go! In Part 4, you will learn about array initialization during declaration. You'll also learn about partial initialization of arrays during declaration, using arrays as parameters to functions, and constant arrays as formal parameters. So, to get started, let's take a look at array initialization during declaration. You can actually initialize your array when you declare it. This slide provides a couple of examples. So here, double sales 5. So this is where we declare the array. We initialize it with the equal sign, and then we list each item, each of the 5 items that we want in the array. In this one, double sales, we did not put how many items, but this is still the declaration. We just didn't say how many items. And the array size will be determined by how many items are in our list. And of course, there's 5 here again, so the computer would know there are 5 elements in this array. Okay, so this is partial initialization of arrays. So there are ways that you can initialize arrays and not have all your data. In this statement, we say int list 10. So we have 10 elements, and then we say equal, and we just put a 0. What that will do, it will assign 0 to every location, all 10 locations in this array, in the list array. Okay, so all 10 components will initialize to 0. In this one, we will initialize list 0, the position 0, to 8, list position 1 to 5, list position 3 to 12, and then all the remaining elements, because there are 10, would be initialized to 0. You can't really do any kind of operation with the array treated as a full one item, single item. Look at this. If we say initialize or integer my list 5, we're going to have 5 items, equal, and we say the items are 0, 4, 8, 12, and 16. Well, what if we wanted your list to match my list? We couldn't say your list equal my list and then it assign those elements. That would not work. You'll get an error. What you have to do, you have to use a for loop and then do each individual element. So we would say integer index equals 0, so we're starting at 0. And then as long as index is less than 5, and we add 1 each time we go through the loop. And then each time, so the first time we go through the loop, your list 0 equals my list 0. So it would copy whatever I have, this 0, over to your list, and it would be in location or position your list 0. And then it go through the loop again, and now index is 1. So your list 1 equals my list 1. So whatever item is in location 1, which is a 4, would be copied over to your list 1, and it would be a 4, and so on until all the elements would be copied over. Now let's talk about using functions with arrays. First of all, arrays are passed by reference only. However, you should not use the and or the ampersand to declare an array as a formal parameter. These are only passed by reference. So you don't have to use the and sign. The size of the array is usually omitted in your array parameter. If it's provided, the compiler just ignores it. The following example illustrates a function header, which includes an array parameter and a parameter specifying the number of elements. So this one, we have void initialize. That's the name of our function, right? Then we have integer list. So here's one of our arrays. We didn't say how many items are in it, and that's okay. We didn't say how many there. And then we have integer list size, and that's the size of the array, okay? We can have void function array as parameter. So there's our function name. Then we have integer list 1. We don't say how many elements are in it. And a double, list 2. So these are two different data types in these arrays. This is integers, an array of integers. This is an array of doubles. Do you remember when a formal parameter, that's the parameter found in the function heading, when it's a reference parameter, that means it's using an address to see the values, then if the formal parameter changes, so does the actual parameter, because they're both looking at the same address location. Well, there is a way to keep that from happening, to keep those values from changing. You can use the const, C-O-N-S-T, constant reserve word. In the example on this slide, the array X can be modified by the function, but the array Y cannot. This one can be modified. It can change values, and that's okay. But this one, it keeps those values the same. This is the end of Chapter 8, Part 4. In the next video, you'll learn about the base address of an array, function return values in arrays, integral data types in arrays, other ways to declare arrays, and searching arrays.